Hey guys, it's Mr. Calderon with Queen My Pawn. I just noticed I didn't start my music. Alexa, play Bach.
Shuffling songs by Johann Sebastian Bach on Amazon Music.
So, in the last video, I covered why integers in Python are so big, integer objects. And it's not the actual integer itself. It's always resizable. In Python, the integer is only 4 bytes, so that's good, right? But when you add all that extra overhead, like the reference, the size, the and some other stuff, which I don't actually remember right now, then you get like 24 bytes of overhead, which is so much. And we don't want to work with that. So thankfully, as I was researching why they're so big, I came across this website. And then let me just share it right now. So it's called Python Speed, but the article here is numbers in Python and how NumPy helps. Well, it talks about why integers are so big because it has a reference count, a pointer to the type of the integer. So one address, the pointer, the reference count, which is counting how many times that integer is used, and the data needed to store the actual object of the integer. And finally, we actually get the integer itself. So that's a lot of stuff, right? But in NumPy, which is something I'm going to introduce to you right now, you have integers that are actually like they're without all that overhead. So let's go ahead and look at the NumPy doc. So this is numpy.org, right? So just go to numpy.org and go to documentation like right away. What is NumPy? Well, I could read this word for word, but no one wants me to do that. So let me just break it down for you. Scientific computing with multidimensional arrays. So have you ever done linear algebra, which you will in college, or if you've already done that, then you know what it is. It's useful to know what a multi-dimensional array can do. So you would just go to array, and pretty sure that it talks to you all about it here, but let's say that you're an absolute beginner, just go to the absolute basics for beginners, and there it is. It tells you about the array, more information, and you see how it looks similar to a actual list. But specifically, arrays in NumPy are made so that you can manipulate them, like reshape them and all that stuff. And look, pretty stuff you can create as well, like these graphs over here at the bottom. You can plot stuff, and you can even make these cool looking things. So the point of this video is that NumPy is a powerful scientific computing library. And like, let's say you want to compute the determinant of a linear system. You put in determinant, and then you can see it's actually under linear algebra. So I put Control F, and there it is. And this function will call my determinant from my array. But the reason why I'm bringing up NumPy is because of the integers, okay? So it's got all these different types, but we're using these because this is Python, not C, right? So we're using Python, and it says this in scalars, right? So here we are, array objects. And this is very interesting, an article to read. And all you have to do is just search the doc for array objects or array objects. There it is. You click that, and here we are. Now look, we go to scalars. Scalars are just numbers or constants. And this is more interesting stuff to read. But why am I showing you this? Because when we go to int right here, well, what I mean to do is int right here is that it has actually defined it for us. And right here, we see that it has numpy.int64. So it represents 64 bits, which means 64 bits in bytes. Well, every And this is how I would do the proportion, right? Just for a refresher, for those that don't know how to do it. Since 1 byte has 8 bits, then how many bytes have 64 bits? And we'll put that right there. Great. So this is how proportions work. If one person can eat 8 pizzas, how many people will it take to eat 64 pizzas? That's basically how it works. So you just do division on both sides, and you can see that the bytes, they're the same units, they cancel out, same with bits. So you end up getting this in red. 1/8. Oh, I gave you the answer. 1/x equals 8/64, but we know that 8/64 simplifies into 1/8. So the answer has to be 8. That means that the size of a NumPy.int 64, this should give me just 8 bytes, right? So how exactly can I find the size of this? Well, it has attributes, and I think it's somewhere in here. So let me see. Now it's definitely in here. I forgot how to find it, and that's not good because I want to show you guys how to find it. But let me show you briefly what it looks like. Import NumPy as NP. So I've imported the NumPy library, and I'm using it as NP, so it's shorter. And now in 64, I can create an integer, and this time I'll make it as 5. So I'll say my int equals this, right? And now my int item size should give me 8. Ta-da! So it's way smaller than 28, you know, because if I did sys get size of 5, that's like 28. That's terrible. I don't want to do that. But if you try sys get size of my int, you can see that it's actually bigger. And the reason why is because it's an object, and you're not trying to use it as an object. You're just trying to use it as a regular integer. So that's why it works. Now, the reason why it's also 32 is because, remember, it contains references to the actual object. It contains a reference count. So, and it also contains the size of it. So you don't want all that overhead. So basically, this is all you want. That's why the size is so small. Anyways, let me show you how to find this. So in order to find, maybe it could be under attributes right here. So you see the attribute section. And so now we can see that you have item size, the length of one element in bytes. So not to be confused with dot size, this is the number of elements. And I only have one number. So if I do my int dot size, it's going to say 1 because I only have one number. So yeah, that's why you should use NumPy. So that definitely makes me feel better about using integers if I'm crammed for space, which I probably won't be, but it's nice to know that I have that option. It's nice to know that I'm that is flexible. So I hope you like this video about me introducing you to a more efficient size object, which is a NumPy. So if you like this video, make sure to give it a like by clicking the gray thumbs up. Make sure to subscribe for more content by clicking the red button, and I'll see you on the next one.